Hello everyone, my name is Kathan and today we will be discussing the problem missing coin sum from the sorting and searching problems of the CSES problem set. Let's begin. Let me read out the question for you. We have n coins with positive integer values. So all the, you can say the values of the coins are positive, the denominations. What is the smallest sum we cannot create using the subset of coins? So we are given, you can say some set of coins and they all have a positive integer value, and they are asking us what is the smallest sum we cannot create by any subset of those coins, right? So we have some set of coins and like they are not necessarily distinct, they can repeat. You tell me the smallest sum which we cannot create. So for the input you can see here, first is integer n, represents number of coins, and then second line has n integers, this represents value of each coin. Important thing is these values are positive. In the output you have to print the one integer, the smallest coin sum that cannot be achieved. Now what do you mean by smallest coin sum? See, we have coins with the positive values, right? Now we will try to create sums like 1, 2, 3, so on, right, from starting to end from positive integer range. You just tell me the smallest coin sum you cannot create. So here they are given example test case here. We'll take this in the iPad when we discuss the question a bit more, but I guess question is clear. We are given some coins with positive values and we have to spit the smallest positive sum that we cannot create using the subset of those coins, right? And that's about the question. Let's go to the iPad and discuss more on this. First things first, let's talk about constraints here. So what are the constraints? Like, you know that number of coins were somewhere order of 10 power 5. So it was specifically 2 into 10 power 5. But that was about number of coins, and individual values being xi was greater than equals to 1, but it was as high as 10 power 9. Now if you have this, it automatically means whenever you are doing sum, addition, multiplication, you please use a long data type. Okay, and what about this 10 power 5? It says firstly you cannot do order of n square solution, because if you do order of n square solution, it's gonna cost you operations 10 power 5 into 10 power 5, which will be 10 power 10. This definitely is greater than the 1 second time limit which is given to us. So in 1 second, if you don't know, you cannot do more than 10 power 8 operations. Fine. So we have to do something better than n square. That is, either you can do n log n, or order of n, or order of log n, or a constant time solution, but I don't think that's possible here. So yeah, I mean, you try any one of these, or maybe n log square n, that also works. But that's the main idea about this, right? Now that's about the constraints. Now let's look at example test case and try to understand what this question is trying to tell us. Now I'll take the same example that is given to us. N is 5, so we have 5 coins, each one with a positive value, which is very important. So 5 coins here, 2, 9, 1, 2, 7. You see, coins can repeat as well, right? A coin with same value can happen multiple times. So what you want to do is, we have an option to select any subset of these coins, right? So how do you form subsets? I guess we already know this. The total number of subsets here are 2 power 5, right? 2 power 5, so 32 minus 1. Minus 1 for the empty subset, right? So I guess this you already know. If you have some n elements, the total number of subsets that can be formed are 2 power 5 minus 1. Total number of non-empty subsets, to be very precise. Fine. Now what they're asking is, what is the smallest sum that you cannot create? That is, go and check in the range 1, 2, 3, 4, 5, so on. Like in the positive range, you tell me the smallest guy here which cannot be created. So let's see what is the smallest sum which cannot be created. Can we create sum 1? Indeed we can. We can just take this guy, right? So yeah, and the corresponding subset is this. Fine. So they're not asking us for the subset, but I'm just showing you. Okay, if you want to create sum 1, this is a subset that will be used. Can you create sum 2? Indeed you can. You can just take 2, right? Because 2 is present in the set of coins we have. Fine. Can we create sum 3? Indeed we can. We can just pick 1 and 2 both. Right? So yeah, the subset will be this. Right? Fine. Can we create sum 4 then? Definitely we can create sum 4. We can pick these two guys. Right? So the corresponding subset here is 2, 2. Okay. Now can we create sum 5? You see what I'm doing? I'm just going linearly from 1, 2, 3, so on and so forth. I'm just trying to find the smallest sum in the positive integer range which cannot be achieved. That will be my answer. Can I create sum 5? Indeed we can. 2, 2, 1. Okay. So the subset here is 2, 2, 1. Okay. The question is, can I create 6? If you see here, you won't be able to create 6. You can create 5, but then you can create 7. You can maybe create 8, and then you can create 9 as well. But yeah, maybe after that we can create 10, so on and so forth, but you cannot create 6. There is no way to create 6. So this is your answer. This is what you have to output. So this is, you can say, the missing coin sum, right? You cannot list the smallest sum which cannot be created using the coins present in this set of coins. So this you want to output. Fine. So how do you approach this question then? Now, if I want to concretize it, firstly we know that xi is greater than 0. That is, or in other words, x is greater than equals to 1. That is, each coin value is positive. Our goal here is find smallest number. This is actually the sum greater than 0 in the positive range. That cannot be formed using some subset of coins, right? So we are given a coins array, right? So we are given a coins array whose size is what? N. And you find me the smallest number greater than 0, because all the values are positive, that cannot be formed using some subset of coins. Fine. Now, what type of observations can you make here? Firstly, first thing you know is the sum will be greater than 0. Okay, so that's a trivial observation, that the number that you're looking after, the sum, you can say the smallest possible sum which is missing, is greater than 0. Okay, what else? This is also a very clear thing to observe, that let's say you sum up all the elements in the array, that is, you do a1 plus a2 plus a3, so on till an, right? So whatever the sum is, let's call this maybe capital S. You cannot also achieve the sum s plus 1, right? All the elements are positive. If you sum up all the elements, you are getting this s. You can definitely not achieve s plus 1 because you have taken all the elements, right? You cannot take an element more than once. That is very important in this question. So this sum can also be not achieved. So what does it say? This says that our answer has to be less than equals to s plus 1, s being the sum of all the elements in the array, or you can say sum of all the values of coins that are given to us, right? So in the question it is clearly mentioned, you have to take a subset of coins. You cannot take a coin more than once. So in the worst case, your answer can be s plus 1, but not more than that. So what I'm saying is, guys, here let's say you have this array 1 2, right? So here you can create some 1, you can create some 2, you can create some 3, you can create some 3. What is this 3? This 3 is actually sum of all the values in the array, right? But you definitely won't be able to create sum greater than 3, right? You definitely won't be able to create the sum s plus 1. Obvious, right? You cannot create a sum greater than sum of all the elements in the array. So your answer is, in the worst case, s plus 1, right? So this thing, like these two things, give you a clear-cut idea that your answer actually belongs to the range 1 till sum of all the elements in the array. Sorry, 1 till sum of all the elements in the array plus 1, right? So we have now a good bound for answer as well. Okay, fine. What next? How do you approach this question? That's also interesting, right? So we have made some observations. Let's try to approach this question now. One thing is clear, that we are trying to form, you can say, trying to find the smallest sum which cannot be achieved, right? So ideally, if we are trying to find the smallest sum we cannot achieve, maybe we should start looking at the coins in sorted order, right? If we can just sort the coins from smaller value to larger value, it might help, right? So maybe let's just sort the array, right? It might help some way. Okay, so we have sorted the array. Now, if you have sorted the array, now let's call this x1, x2, x3, x4, so on. Let's say xn minus 1, xn in sorted order. Fine. We are sorting the array. Why? Because we are trying to find the smallest sum which cannot be achieved. So maybe by sorting at the array, we might be able to simplify the question a bit. Okay. So this array is sorted. Now what? Remember, we are after smallest sum, whereafter the smallest sum greater than equals to 1, which cannot be achieved. Our answer is greater than equals to 1, and we know that our answer is actually less than equals to sum of all the elements plus 1. These things we know. Okay, you can say the smallest answer can be 1 as well. So this clearly says that if this x1 is not equal to 1, our answer is 1, right? If the smallest value in the array is not 1, then our answer is 1, right? This is the smallest sum you cannot create. But let's say x1 is indeed 1. So if x1 is 1, we can create a sum 1. Maybe let me denote it like this. So we can create sum 1. Alright, so if x1 is 1, what do you know about x2 then? What are all the possible values of x2, by the way, guys? You know that this array is sorted. Maybe I can write it here, right? This array is sorted. Now let's look at all the possible values of x2 that we can have. So this x2 will be of course greater than equals to x1, right? So it can have all the values in range 1, 2, 3, 4, so on, right? Because x1 is 1. Okay. Now let's say x2 is actually 1. Now remember, we can create sum 1. Now we are looking to check whether I can create sum 2 or not, right? So our answer lies in range 1, 2, 3, 4, so on till s plus 1, right? So don't forget that we are looking for a number in this range. Fine. So we are looking that if we can create sum 2 or not. For x2, we have all these options. Let's say x2 was 1. If x2 is 1, can we create sum 2? See, we are able to create sum 1. Fine. If x2 is 1, we can just take this 1 with this guy and we can create sum 2. So indeed, we can create sum 2 in this case. Yes. So if x1 is 1 and x2 is 1, we can create sum 1 and 2 both. How? If you want to create sum 1, you just take this guy, right? So take this as a subset. If you want to create sum 2, you can create 1, 1, right? So what I mean by this here is, if x2 is 1, we can create sum 1 and 2. Fine. Let's see. So for x2 equals to 1, yeah, we can create sum 2 as well. Okay, but what if x2 was 2? Then can you create sum 2? Right? Remember, when I am here, when I am checking x2, I'm trying to find whether I can create sum 2 or not. Right? So what if x2 was instead 2? So now can you create sum 2? Indeed you can, right? You can just take this guy and you can create sum 2. Fine. So yeah, you can create sum 1, you can create sum 2, but remember, now you have 2 as well, right? Remember, when you had x1 equals to 1, you only able to create sum 1. But when x2 is 2, now you can create sum 1 by taking x1 equals to 1. Create sum 2 by taking x2 equals to 2. But now you can also take both of them and create sum 3. So sum 3 is also on the cards. Okay, so when x2 is 2, you can create sum 1, 2 and 3 as well. That's very great. What next? So for x1 equals to 1 and x1 equals to 2, you can create sum equals to 2. Right? Remember, when I was checking x2, I was trying to find whether I can create sum 2 or not. Okay. So if x2 turned out to be 1, I can create sum 1 and 2. If x2 turned out to be 2, I could create sum 1, 2 and 3 as well. Great. Now let's talk about x2 equals to 3. This will be interesting. The real learning lies here. Pay your utmost attention here. x2 is 3. Now x2 is 3 here. Can you create sum 2? See, x1 was 1, you are able to create sum 1. Now x2 is 3. So now here you can create sum 3 directly. You cannot create sum 2. There's no way. Right? x1 is 1, x2 is 3. There is no way you can create sum 2. Similarly, if you have x2 equals to 4, right? Even if you take x2 equals to 4, 5, 6, so on and so forth, you cannot create sum 2. So what does it say? What does it say? If x2 is greater than 2, your answer is simply 2. Right? Again, when x1 is 1, you can create sum 1. Then for x2, if it is 1, yeah, you can create sum 2. If it is 2, yes, you can create sum 2, but you can also create sum 3. But if x2 is greater than 2, you cannot create sum 2. right? So here your answer will be 2. Let's take it one more step further, like deciding upon value of x3, then you'll get it. But all that you need to know right now is if x1 is not 1, your answer is 1. If x1 is 1 and if x2 is greater than 2, then your answer is 2, right? And I just showed you how. Now let's take this case and try to expand it. That is x1 is 1 and x2 is 2. If x1 is 1 and x2 is 2, this means you can create all the sums in range 1, 2 and 3, right? I just showed you how. Now what do you know about x3, right? So how can x3 affect my decision? So here first things we know is the largest sum that you can create right now is 3, right? It means I can create sums 1, 2 and 3. Fine. Now what do you know about x3? Firstly, it has to be greater than equals to x2. So its value will be what? X3 will belong to 2, 3, 4, 5, so on, right? So this is what I know. Okay. Now let's go about it step by step. Now let's say x3 is 2. Okay. If x3 is 2, then can you create sum 4? See, remember, I can create all the sums in range 1, 2, 3. Now I'm after, can I create sum 4? Right? So when I'm looking at x3, I want to know, can I create sum 4? Okay. So if x3 is 2, can you create sum 4? See, you can create all the sums in range 1, 2, 3. x3 is 2. You can just associate this 2 with 2 and you can create sum 4 very happily. So yeah, in this case, I can create sum 4. Okay. Now what if x3 was 3? Can I create sum 4 now? Remember, the largest sum that you were able to create till now was 3. If we associate this 3 with this 1, we can create sum 4. Fine. I can create sum 4 here. Great. Now, what if x3 was 4? Now can you create sum 4? Of course, you just take this guy itself and you can create sum 4. In this case also, you can create sum 4. Great. Now what? In this case, if x3 was 5, let's say x3 was 5, can you create sum 4 now? So you are only able to create sums till 1, 2 and 3. And if you take a value which is greater than the sum you are after, which is greater than the value, which is greater than the sum that you are after, you definitely cannot create that sum, right? Again, you know that when x1 was 1 and x2 was 2, you could create all the sums in range 1, 2 and 3. And you were after the sum 4. Now think about this just a little bit. If the value of x3 is actually greater than this, you cannot create this sum. Why? See, if the value was greater than equals to this guy, you can of course create that sum. Why? Because in the worst case also, that guy can itself be the sum you're looking for. Or you can associate the smaller values with one of the guys here and can achieve the sum. Right? So in the worst case, if it was 4, you can create 4. If it was 3, you can associate it with 1. If it was 2, you can associate it with 2. Right? Very important. If you're looking for a sum, let's say, if you're looking for a sum here, so if the largest value that you were able to create previously was L, now you're looking for the sum L plus 1. In the worst case, if this value is given to you, you can create the sum L plus 1. If something less than that is given to you, let's say you are given L itself, 3, you can associate it with 1 and achieve the sum L plus 1. If L minus 1 was given to you, that is this 2 was given to you, you can associate it with 2 and achieve the sum. Make sense? So one thing is clear, if the current sum that you are looking for, if this L plus 1, or you can say the current coin that you have, is greater than L plus 1. What is L? L is the largest sum you could achieve by considering the previous coin. Then your answer is simply L plus 1. Makes sense. So with this condition cleared out, now let's think about how will this L be affected when you try to select the next element. That is, once I have selected x1, x2 and x3, when I try to choose x4, what is the largest possible sum I can create using the previous guys? Okay, more clearly, when I choose x1 equals to 1, when I am coming to choose x2, the largest sum that I am able to create till now is 1. If I have taken x1 equals to 1, x2 equals to 1, and when I am trying to use x3, the largest sum that I can create till now is 2, which is this. Again, if I have taken x1 equals to 1 and x2 equals to 2, and when I'm trying to choose x3 now, the largest sum that I'm able to create till now is 3, right? Now, how will the choice, this L will change when I choose x3, one of these guys, 2, 3, 4, because 5 anyway I cannot choose, right? Anything greater than 5 I cannot choose. I've got my answer. Let's see how L is getting affected. This will be interesting. Maybe let me write it here itself. This condition is great. So if the current guy is greater than L plus 1, what is L here? L is the largest sum that you can create in the after selecting the previous guy, right? After selecting the previous coin. Okay. Now, what if x3 was 2? Remember, earlier we were able to create all the sums in range 1, 2, and 3. Maybe I can write in different color. You are able to create all the sums in range 1, 2, and 3. Now, how will L be affected? So, L was right now 3. If x3 is 2, if you decide to take 2, you can associate this 2 with 1. So, then you can get some 3. Fine. The L is not increased. You can associate it with 2. So, 2 plus 2 is 4. Yeah, you can get some 4. Then when you associate with this 3, you can get some 5. Right? So, these are the, you can say all the sums that you can create using elements x1, x2. Yeah, x1 and x2. But when I chose x3 equals to 2, you can decide to put this 2 in any of this subsets, right? Any of the subsets corresponding to this sums, right? So if you decide to put it with 2, you will get sum 4. If you decide to put it with 3, you will get a sum 5. In other words, the new L, let me call it L dash, will actually be equal to 5. Okay, fine. What if x3 was 3? Okay, then what happens? You can maybe decide to associate this 3 with 1. Then in that case, you will get sum 4. You can maybe decide to associate with 2. Then in that case, you will get sum 5. You can maybe decide to associate with this 3. So when I say associate with this value means put this 3 in the subset corresponding to this sum. That's what I mean. Okay. So in that case, you can get a sum 6. In other words, of course, you can create sum 4. That's what you are after. But along with it, you can also create sum 5 and 6. In simple words, you just added this 3 with 3, right? So this L dash was 6. Don't worry, we'll get it. We have x3 equals to 4. Now, in the previous round, when you chose x1 and x2, we were able to create these 3 sums. Now you can either decide to put this 4 with the subset corresponding to this 1 sum. You can decide to put this 4 with the subset corresponding to 2 sum, or you can decide to put 4 with the subset corresponding to this 3 sum, right? So if you decide to put this here, you will get sum 5. Okay. If you decide to put this here, you'll get sum 6. If you decide to put this here, you'll get sum 7. Okay. There's one more. You can take this guy itself, right? So this was the case here itself, right? So you could take standalone subset like this, but these sums are already present. So if x3 is 4, you can create sum 4. You can create sum 5. You can create sum 6. Or you can create sum 7. So L dash is turning out to be 7. In other words, if I have to summarize, L for the next round is actually become equal to the current value of L plus whatever x3 you choose, right? Simple. If you chose x3 equals to 2, in the current range, it will be extended by 2. It will be extended by 2, right? If you choose x3 equals to 3, it will be extended by 3, 4, 5, and 6. If you chose 4, it will be extended by 4, 5, 6, 7. And this also is an important update step. Now I guess we have covered enough ground that we can actually come up with an algorithm now. So I could have stated this algorithm earlier and explained you the working of it, but I wanted to show you how you can arrive at the algorithm. So we have covered enough ground now, and now let's state the algorithm. So first things first, we just sort the array of coins that we have. Okay. Now, what we do is currently when you have not processed any single coin, the largest sum that we can create till now is 0, right? In other words, if you have not processed x1, you are just about to process x1, the largest sum that you have till now is 0, right? Now you are trying to create some L plus 1. Remember, now everything will connect. So now when you are at x1, you will try to create the sum L plus 1. So what you'll do is you will go from all the coins, that is, you will go from coins I equals to 1 till Okay, remember we have sorted the array. Now first condition, what is the first condition? If the current coin you have is greater than L plus 1, right? For example, when you are trying to pick x1, and you know the largest sum till now that was created is 0. If this x1 is greater than 1, then you cannot create sum 1. So here I'll write the bad condition. So if xi is greater than L plus 1, right? If xi, current value of xi is greater than L plus 1, L being the largest sum that you have created using the elements x1 till xi minus 1, right? Here you cannot create, your answer is simply L plus 1. You cannot create the sum L plus 1, and here maybe you can return out of the function. Fine. Otherwise, like if you have not returned, L will be updated. How will L be updated? Now you can definitely create L plus 1 sum, but you can create some more sums. So this L will be updated with L plus x3, sorry, L plus xi, right? Again, when you're trying to, let's say we are trying to choose value for x1, L was 0. Now, if x1 is greater than L plus 1, x1 is greater than 1, you cannot create, basically you've got your answer. The smallest possible sum that cannot be created is simply L plus 1 with this 1 itself. But if it can be created, now you will choose x1, right? So earlier you can say the sum set was 0, and now when you try to choose x2, what should be the value of L? To the 0 you will add simply 1, right? So this condition, guys, right? You just add the current value. So now here, if this was 1, you will add 1 to it. So this now L becomes 1. Similarly, you go on, right? So I guess I'll not explain this now because we have already seen how this value of L progresses. Fine. So L is greater than L plus xi. Great. Now when this loop ends and you have still not returned, it means you can create all the values in a range 1 till the sum. Sum meaning the sum of all the elements in the array, right? So in this case, you can maybe just print, what? You can maybe print sum of all the array elements plus 1, or if you observe a little bit, this L's value will actually be equal to sum of all the array elements, because what you're effectively doing is, guys, to L you are first adding x1, then to this L you are adding x2, then you're adding x3, and it was initialized to 0. So eventually, if this loop has ended and you've still not returned, this L value will anyway will be equal to the sum of all the elements. So you can just print L here, right? So you can just print L and it will be answer, right? So yeah, I mean that's the pseudocode. Simple. You start. You first sort the array. You start with L equals to 0. It means before you have chosen the first guy, the largest sum that you can create till now is 0. Then you try to pick a guy. If that guy is greater than L plus 1, L plus 1 sum cannot be created. I just showed you how. Otherwise, like you can print the answer. This is the smallest sum greater than 0 which cannot be created. You can return. But if this sum can be created, you're going to update the largest sum that will be created for when you try to select the next guy, which is simply equal to L plus xi. If you've ended the loop but still not returned, it means you can create all the sums in range 1 to s. In the end, you can just print L, or in other words, you can print L plus 1, right? Why L plus 1? L is actually sum of all their elements, right? So L plus 1 that you can create. Now that's about this approach. What is the time complexity here, guys? This loop is simply order of n. The sorting will consume n log n, right? So the time complexity here is simply n log n, right? And what is the space complexity? I don't think we are using any extra space. The space complexity will be order of 1, right? So that's about the pseudocode. And if you want, I can do a dry run here and we can solidify understanding, and then we can move on to the final code. Let's do the dry run on the same example that was given to us. Let's see. So the example, I'll just sort the coin values we'll have. So we had 1, 2, 2, 7 and 9. So initially we start with L equals to 0. Right, we start with L equals 0. So before you have chosen the first guy, the largest sum that you can create till now is 1. Okay. So is 1 greater than L plus 1? No, it's not, right? So this can be selected, and now the largest sum will be actually equal to 1. In other words, x1 was 1. Okay, fine. Now we come to x2. Now I'll ask, is this x2 greater than L plus 1? So this is the condition I ask, right? And if this condition is, you can say true, I got my answer. But if this condition is false, I'll update L, right? Is x2 greater than L plus 1? It means, is 2 greater than 2? No, 2 is not greater than 2. So fine, I can create my answer. So basically, I can create sum equals to 2. Okay, so I'll update L. L will be updated to 1 plus 2, which is 3. Okay, now I'll come here. Okay, remember the sum I'm looking after is 4. Now I'll ask, is x2 greater than L plus 1? That is 2 greater than 4? No, 2 is not greater than 4. So I can definitely create sum 4. So I'll update L again. So it'll be updated to what? 3 plus 2, 5. 3 plus 2, 5. And I'll move ahead. Okay, again, let's stop here and try to see what has happened till now. When you are at 7, L is 5. It means you can create all the sums in range 1, 2, 3, 4, 5. Right? How? 1, 2, 3, 4, or 5. Right? Now we're at 7. Now we'll ask, is 7 greater than 6? L plus 1, right? It is indeed greater than 6. So this 6 cannot be created. And we'll print this 6 as our answer. Right? And so yeah, I mean, that's about the dry run. I hope you have understood the explanation till now, like how I reached this pseudocode. Like, I could have done the either way. I could have just stated the code to you and then explained you why this works. But I thought about, let's go step by step and figuring out how can we reach this solution instead. So if you like that approach, please comment understood in the comment section of the video, and we can move to the coding part. Alright, so guys, here's the code. First things first, I'm taking all the array. Alright, so here's the code, guys. First things first, I'm taking the coins input, right? So n being the number of coins, and here in the array, I'm storing all the coins. Remember, I'm taking all of them as long here. Why? Because I have to like add something to the largest sum and all, right? So I have to do some additions. That's why it's better to take them as long. Then I'll sort the array. Fine. Then I'll initialize this k. This k is actually the largest sum till now. Okay. Then I'll go through all the coins. Now when I'm inside the loop, I'm trying to see, can we make this sum k plus 1, right? That's what we try to ask ourselves. But if the current coin is greater than k plus 1, if current coin is greater than the largest value you can achieve in the previous round plus 1, we cannot achieve this k. We cannot get this k plus 1 sum. So we print it and return. Right. But if this is not the case, now we can make all the sums in range 0 to k plus ARR of I. 0, like you could write 1 here, but you can write 0 if you don't select anything. However, that doesn't change the question. Fine. So you will add 2k ARR of I. If this loop has ended and you have still not returned, it means we can create all the sums in range 0 to sum of ARR, right? Or 1 to sum of ARR. 0 is inconsequential here because in which way we care that we are able to create the sums in range 1 to sum of ARR. Fine. So if we can do that, then answer is simply sum of ARR plus 1. But if this loop has ended, k has indeed become sum of all the values of ARR, right? Because in the k you add elements 1 by 1. So you can just write k plus 1. Fine. There is no need to run another loop. And what is the time complexity here? N log n, just for sorting. And this is simply order of n loop. So that it doesn't, like, asymptotically, we are just doing n log n work. And space complexity is order of 1. We are not using any extra space here. So yeah, I mean, that was about the video, guys. I hope you liked it. If you did, please give it a thumbs up. And I'll see you in the next one.